Okay, folks. Top part has to do with parallel and perpendicular lines. So when we look right here, you've got two different forms. This is ax plus by equals c form. So the slope is opposite of a over b. A is the coefficient in front of the x, so a is -4, so the opposite of a would be +4. B is 2 to give us a slope of 2 for that first equation. In the second equation, it's in slope-intercept form, which means you can pop that slope right out. There's the slope. When we compare these two, they have a name. It's two words. When we compare these two numbers, what are the two words? The word for signs being different. The word for the fraction being flipped. Well, there's another. Reciprocal. So, y'all, these are opposite reciprocal slopes. So what kind of lines are they? These are perpendicular lines. Okay? All right, this one. I did my very best to see if I could confuse y'all. So let's see, and hopefully y'all will participate in this. How many people said these lines are parallel? Raise your hand. 2, 3, 4. Okay. 5. How many people said these lines are perpendicular? Raise your hand. And neither. Okay. All right. These lines are parallel because they only have a y in them. So this is a horizontal line. This is a horizontal line. Y'all, this doesn't matter. It's basically telling you that at y equals 3, that's where the horizontal line is drawn. And at y equals -1/3, that's where the horizontal line is drawn. But these are both horizontal lines. So they are parallel. What I did was make that y-intercept look like an opposite reciprocal to see if y'all would pick perpendicular. It is not perpendicular. If you only have a y in an equation, it is a horizontal line. So these are both horizontal lines. We good? Okay. Here we go. Tried to give y'all a little bit different problem this time. We're still got a quadratic. Does it open up or down? It opens up, and the reason why is your x squared term is positive. In front of the x squared, it's positive. What's my y-intercept? The y-intercept is -9. Folks, the missing term is the linear or the x term. In other words, if you were to put it back in, it would look like this. Okay, but they don't put that in there. But y'all, the b is what is missing. It's not the c. The c is -9. Y-intercept's -9. Now I need my x-intercepts. We need to factor this. Well, it's not there anymore. This is a difference of squares. So I'm going to go ahead and write that. This is a difference of squares. So there is no work to do at all. It is 2 parentheses. X's go in the front slots. Anybody remember what my signs are for difference of squares?
Plus and minus.
Yeah, one is a plus and one is a minus, and it doesn't matter which one is which because everything else in the parentheses is the same. And who knows what goes in the back here? It's a 3. Okay, y'all don't be fooled. And by the way, it's because 3 times 3 is 9. That's why it breaks down into 3s. Y'all don't be fooled. One of your answer choices for something like this would have 9s here, just to see if you put the 9 there, okay? So now if we continue this, I think everybody now knows what the x-intercepts are, but if we mathematically continue this, we set each factor equal to 0, and we solve. So here I subtract 3 on each side, and I get a -3. Here I add 3 on each side, and I get a +3. So my x-intercepts are -3 and +3. Did anybody get that? Did anybody know it was a difference of squares? Okay. Rest of us need to catch on. I can guarantee you a difference of squares problem on a standardized test. They're going to check to see if you know this. Might even have a greatest common factor in there beforehand. Okay. Axis of symmetry. This formula will not be given to you on a standardized test. So eventually, you know, I've got to stop giving you this guy. Okay? But it's the opposite of B over 2A. So if we look at how I rewrote this, can somebody tell me what A is?
X,
A is a number. Yes, it is the coefficient in front of the x squared. And if there's nothing there, it's understood to be a 1. What is my B? 0. And then if you needed it, C is -9. That's my y-intercept. Okay, so B is 0. Y'all, there's no need to be afraid of a 0. Okay? So when it says opposite of B, y'all, there's no such thing as -0. It's just 0. Okay, divided by 2 blank, and A is 1. So this is 0 divided by 2. What is 0 divided by 2? It's 0. So my axis of symmetry is at x equals 0. In other words, it's the y-axis. That's the axis of symmetry. Okay? If I want my vertex, I take my axis of symmetry and do what? I plug it in. So what does it sound like? Blank squared minus 9. Blank squared minus 9, and I plug the x part in the blank. And again, because the axis of symmetry goes through the vertex, the x coordinate is 0. And then 0 squared is 0. So 0, -9 is my vertex. Do we have a maximum or a minimum value for this curve? We have a minimum. The reason why is it opens up, and if it opens up, there's actually a bottom to this parabola. So we do have a minimum. And what is that minimum value?
-9.
It is the y-coordinate of the vertex. It is -9. And the idea is to think through all this information. Y'all, I'm trying to lead you to the graph, but typically on a standardized test, they're just going to say, what is the vertex of x squared minus 9? And you've got to go, okay, vertex, vertex, vertex. What do I need to do? I need to do opposite of B over 2A. Then I need to plug it back in. It's not going to be a series of questions like this. It's just they're going to have one question picked out. Okay? So now with all that information, we said it turns up, so we know it's not this one. And now we've got these 3. Which one did y'all pick for your answer?
D.
It is D. That's correct. Okay? These guys are double roots. These guys are double roots. So just so you know, this function right here, and y'all might want to write it down, this function right here is x minus 3 squared. In other words, it's a double root. The solution, it's one of them. It's a 3. This one right here would be the function f of x equals x plus 3 squared. Just letting you know. Just to letting you know. We good? Yeah? All right. Okay, so we are going to add to our notebook today. It's not going to be very grueling. I just want you to see some different problems you can have for sequences. And y'all, for the most part, we're pretty much done with sequences, believe it or not, just maybe a little bit more practicing. So if you'll pull your notebook out, and let's get our notebook open to the correct page, and then that way when you start cutting your pieces, it's not a lot, but when you start cutting your pieces, you'll already have your notebook to the right page. Okay. Oh, and I meant to tell y'all, if you turned in your extra credit, you know, maybe you turned it in Thursday, y'all, I did not get a chance to enter any of that. I have been doing some family stuff since I walked out the door Thursday, so I do apologize, but I hope you know I am going to try to get those in, okay? They're in a basket back there. Okay, so let's see where we were. Okay, there's 8, solving quadratics. Okay, then we had 9 is where we had our formulas for the geometric sequence. Page 9 all the way across. And I think that brings us to blank pages when we flip 2 in the center. So let's lay The left side, obviously, we're going to do an L. The middle, we're going to do an E. The right-hand side, we're going to do a Q. And let's label all 3 pages. I believe they are page 10. Is that correct? You can put a line through quadratic, because with sequences, we do not do quadratics in Math 1. So you can put a line through quadratic. And when you get it open like this, I'm going to give you a half sheet, and you need to cut it out. Cut out each box, and I tried to fix it where the boxes are butted up against each other so you don't have to cut twice. So hopefully shouldn't take you very long. And then when you get these cut out, I want you to figure out which ones go under linear, which ones go under exponential, but please do not glue them yet, because we're going to glue them a special way so that we have room to work the problems out, okay? That I have more. Y'all need to. There's a pair. All right. All right, so that's the way I've got them laid out. And let's glue. If you do not have a calculator for you, yourself, not to share, then would you look around and grab one, please? If you do not have a calculator, would you look around and grab one? Because part of what I'm going to show you is on the calculator. All right. I'm seeing some people still gluing, so I'm just going to give another couple seconds here, let everybody get going. All right, let us get started. Y'all, I'm going to start with the easiest one first. It's actually the word problem, okay? The reason why it's the word problem is because, y'all, the word problem's not really asking you to do anything out of the ordinary that you wouldn't have done already in a Delta Math. It's just in terms of words, okay? So we have to recognize that it says the first row is 56. Y'all, when it says the first row, they're literally telling you the first term of that sequence is 56. Okay, you're going to find out later, as in beginning of May, that if they say something about initial, y'all, that's not first. So that's why I'm really strongly saying, notice that they are using that word first row. Okay, when you see information that says first of something, y'all, you can write this as a sequence. Okay, when it says initial, you gotta be careful. We're gonna do that later. End of the month, beginning of May. Okay, so we've got 56. The second term is 59, and the third term is 62. Just to get you used to seeing the notation again. What is A sub 1? It's there. What's that little one mean?
The first term.
First term. A sub 1 means the value of the first term. What is the value of the first term? Yeah, we got to get used to seeing this notation. Okay, and we know that there is a common difference, and what is that? Common difference, we are adding 3. Okay, now let's go on to see what it's asking us. If the pattern continues, how many people will there be in the 10th row? It is asking us for the value of the 10th term. That is what it's asking. Okay, now, can we just keep adding 3? We sure can, but I'm going to go another step and we're going to write the equation and plug in. But I do realize you can add 3 until you get to the 10th term. But I want to remind you of the equation. Arithmetic is A sub n equals A sub 1 plus D parentheses n minus 1. Okay? So the first term, the value is 56. The D is a positive 3, so I'm going to put plus 3, parentheses, n minus 1. This is our equation. And if I want the value of the 10th term, what do I do right here? If I want the value of the 10th term, what do I do?
Replace it in with the 10.
Yeah, we plug in 10 for n. So it would be 56 plus 3, parentheses, 10 minus 1. I'm going to continue this as if I do not have a calculator. 56 plus 3 times 9, because 10 minus 1 is 9. That would be 56 plus 27. 3 times 9 is 27. And let's see, 7, 14, 13, 83, I believe. So in the 10th row, there would be 83 people sitting there. Just another reminder, if you go in your calculator, and y'all may want to do this with me, if you go in your calculator under y equals, and you need to clear anything out that's in there, okay, if you enter your equation, so it would be 56 plus 3 parentheses, we do not have an n, we're going to use an x minus 1. Notice, y'all, when I'm under y equals, I've got a variable in here. A lot of y'all are going there and like putting your 10 right there. It's not a problem. When you go to your table, it's just the answer is going to be written thousands of times. But y'all, if you put that x in there, what you're doing is creating an equation so that when you go to your table, you can get the value of any term you want. So if you scroll, you'll see the first term, the value is 56, 59, 62, and I think it said the 10th term, so you'll notice that if you go down to the 10th term, your value is 83. So that is a way to do that. You can do that on Desmos as well. If you enter the equation into Desmos as y equals, you can make a table. So let me show you that. For my video, the children will not be able to see this, but yeah, I'm just going to do y equals. You need to start it with y equals or f of x or something equals, and then I think what we said is 56 plus 3 parentheses x minus 1. Okay, and there's our line. And y'all, you can go under, I think, the little toolbox and change it to a table. And no, it doesn't, you can't keep scrolling, but you could literally enter your 10 right there. There she is. Okay, so just showing you that it does work for Desmos as well. Are we good? Okay, so let's get to some harder ones. All right, let's go up here. The first term of an arithmetic sequence is 5. Okay, the common difference is -4. And y'all, they've changed this up. And if you're not paying close attention, you could think that you're supposed to plug in this number for n. This is not n. Notice it says, what term number? Y'all, we don't know n. That's what we got to find now. what term number in this sequence has a value of negative 43? Okay, so you might want to highlight what term number, because we have to find n. We are finding n. That's different than what you did all last week, y'all. Okay? So, I'm going to write my formula. It's arithmetic. So, it's a sub n equals a sub 1 plus d parentheses n minus 1. And y'all, if we are wanting to find n, y'all, if we want to find n, that means I've got to have a number to put in place of all the variables here, so that n is the only one left. So that n is the only one left. I've got to have something to go for all of these. Okay, well, what's going to go in the place of a sub 1? 5. What's going to go in the place of d?
-4.
And what's going to go over here on the other side? -43. Y'all notice it's saying the value is -43. Y'all, that's kind of like a y. And they want the x. Kind of like a y. It goes on the other side. So y'all, the value, that's your a sub n. -43 goes right there. Now we've got numbers all the way across this equation with the exception of n, and we're going to solve for it. So, I'm going to put -43 on the other side of the equal sign. Y'all do this with me. A sub 1 is 5 minus 4, parentheses, n minus 1. And y'all, all it is a multi-step linear equation. That's all it is. What would be my first step to solve this?
Distribute.
Yep, we're going to distribute. So we've got -43 equals 5, and then -4 times n is -4n. -4 times -1 is +4. What next?
Add 43.
I wouldn't do that next. Yeah, we're going to combine like terms, so we got a 5 and a 4 to combine. It gives us 9. And y'all, now you'll notice you have a two-step equation. So what do? Subtract 9 on both sides. I'm running out of room. Someone come up here. We got -4n equals, and when I combine 9, 10, 11, 12, is that -52, I believe? And what's my last step? Divide both sides by -4. So all we're doing is solving a multi-step equation. And y'all, here's the thing. If we're looking for the term number, should I get an answer like 9.6? 10.2? No, because y'all, term number means, is it term number 1, term number 2, term number 3? So y'all, we shouldn't be getting decimals at this point. And we shouldn't be getting negative numbers at this point. Okay? So, let's see, 4 goes into 5 one time with 1 left over. That's 12. It is term number 13, folks. It is term number 13. Now, if everybody would, go to the calculator with me, trying to give you all the sources that I can give you, folks. We're going to enter the right-hand side of this equation here. 5 minus 4, parentheses, x minus 1. 5 minus 4, parentheses, x minus 1. We're going to enter it under y equals.
Try to get it out.
Okay. There's a bunch of people not popping this stuff in the calculator. And folks, I mean, that's kind of what happens during the test is I get people to call me over and they're like, Ms. Bashik, can you help? Y'all, I'm helping now. I can't help during the test. I'm helping now. So I'm begging y'all, let's throw this in the calculator. Let's take a moment and just pop it in the calculator. Does everybody have a calculator? Okay. So I'm putting that equation in. Notice there's an X there. Okay, so let's go back to the table again. We're going to press second table. Okay, and y'all, this time what I'm getting to is, we know the value is -43. So we're looking over here for negative 43. Okay? Right here in yellow, top right. So you're going to press your yellow button and then the graph button. All right, there it is. There's the value of negative 43. It is term number 13. If I'm not mistaken in Desmos, I don't know that you can enter the y and it backs up and finds the x for you. Let's give it a try. Let's give it a whirl. The first term was 5. And then my common difference was negative 4. So that's that. So let's see what happens. Yeah, it won't let you just go put the y value in. So you would basically just have to keep trying values until the negative 43 showed up, if you did it in Desmos. Okay. I mean, if you know it's a y, you could treat it like a system and go in and put y equals negative 43. And then you could find what? What would you be finding? If you got two equations in there, what would you be finding? Starts with an I. The intersection. So see, if you found the intersection, you could find it's 13 as well. Lots of different things. Tables will help you get answers. Graphs will help you get answers. And then obviously, if they take the calculator away from you, you've got to realize that you're writing an equation and solving it. Okay? Okay, now, I want to flip. I know we haven't done this one, but y'all, because we did this one, I want to flip over and do the geometric one. It's important, because here we were able to solve it by hand, and I want you guys to see something here, okay? So let's flip over real quick. Geometric sequence. The first term is 5. The common ratio is negative 2. Notice its question is, what term number? We are looking for n. They are not giving us n. What term number has a value of negative 2,560? Okay, so let's remember that our formula for geometric is a sub n equals a sub 1, which gets multiplied by the r and raised to the n minus 1. That's our formula. Okay, so this is a value. It goes on the other side. So it'd be negative 2560 equals, the first term is what? The value of the first term is what? 5. And what is my common ratio? Negative 2 raised to the n minus 1. Okay, y'all, you don't remember, but if you look back a page, under exponential, we have an example of an exponential, and we have written here in Math 1, we do not solve exponential equations. The only thing you can do in Math 1 is put it in the calculator, put it in Desmos, and you can either look in a table or you can find the intersection. You will learn how to solve things like this, Math 3 maybe, okay? So, if you want to write a little note, in Math 1, we do not algebraically solve exponentials. That's more like Math 3. So instead, what we're going to do is put this under y equals. We're going to put this under y equals, and we're going to find the intersection. Y'all, we can also go in the table, just like we did on the other one. So I'm going to demonstrate both of them. So I'll let y'all get that written down. And just a couple of words, y'all. In your mind, you might say to yourself, Miss Batchick, we have been solving exponentials. If you want to know the 20th term, we've been putting a 20 there and putting it in the calculator. Y'all, that's not solving an exponential equation. All that is plugging in. That's putting in something and getting out something. Y'all, solving an equation is when there's something over here. That's when you've got to solve an equation. So we have never done that. If they want the value of the 20th term and you just plug a 20 in, that's not solving an equation. That's called evaluating. So just let you know, it's when there's something over here that you're actually solving that equation, and we don't do that in Math 1 for exponentials, okay? So let me demonstrate. Again, the folks watching the video are not going to be able to see the Desmos, but I will try to say what I'm doing. In the first row, I'm going to put in y equals, and I'm going to put in 5 parentheses, negative 2, close the parenthesis, caret key, and we need to open a parenthesis and put in x minus 1. Then we're going to do y equals, and I'm going to put the other side of that equation in, which is negative 2,560, I believe. Negative 2,560. And yes, we're probably going to need to really zoom out. See if we can find this thing. Trying to figure out why this little guy's not showing up. Let me try him again. Might just be that we don't have our window right. Now let me try this. Let's do my y. From negative 3,000. Cannot get him to show up. Well, I'm going to have to look at that, y'all. I can't get him to show up. I don't know what I've done wrong. I've got a parenthesis right there. Is that... Are you saying don't put one? Yeah, you can't have a minus 1 down below, though, is the problem. See, that's not the right one. The minus 1's got to be up top. So I'll look at it and see if I can figure out. It might just be, I don't know. I'm not going to answer because I don't know. Okay, so let's go back to our calculator. Let's hope that works. Okay, so let's go to y equals. Five parentheses, negative 2. Might be that I've got it negative 2 raised to the x minus 1. Again, I'm putting the right-hand side in there, and I'm using an x. And let's go to our table, and we're looking for negative 2,560. Mine just happened to be right there. So what term number is that? 10th term. In theory, it should work in Desmos. I'll have to look at it and figure out why not. Okay? Yeah. Go back to y equals. If you go to y equals, basically what I did is I just put this right here in. I just put that right there in. And then if you go to the table, it actually gives you the values and the n. So here's your term numbers, and there's the value. We good? All right. All right, while we're over on this side, might as well do this bottom. Charles planted 8 seeds on the first day, and again, very important, y'all, you're going to see shortly here in a few weeks after spring break. I love that word, spring break. Y'all, you're going to see that word first is going to be very important, because if it says he initially planted 8 seeds, that is not, you would not write a sequence for that. I mean, you could, but initially is not first. Initially is not first. Initially is actually the 0 term. First is the first term. Okay, so looking for that word first. So 8, 16, and 32. So what is the value of my first term? 8. We have a common ratio. What is it?
Times 2.
Yep, it's 2. And notice it says if the pattern continues, how many seeds will Charles plant on the 9th day? Y'all, they are giving me the N. Y'all, they are giving me the N this time. All I'm doing is plugging into the formula. That's it. They're giving me the N. So A sub N equals, the first term is 8, parentheses, my common ratio is 2, raised to the N minus 1, and what I'm going to do in the calculator is I am going to put a 9 in place of the N. I am either going to put it in parentheses or just know that 9 minus 1 is what? And just raise it to the 8th power. So y'all, again, y'all, I'm really not solving an equation here. All I'm doing is plugging in. So 8 parentheses 2, close the parenthesis. Don't forget your caret key, folks. You got to have a caret key. Open a parenthesis, type in 9 minus 1. The value of the 9th day, Charles is going to plant 2,048 tomato seeds. Y'all okay there? Y'all good? Y'all, if you notice, it's all about, you got to be able to write these formulas, and you're going to have to know these formulas. You'll have to know the one for geometric and the one for arithmetic. You got to know them, because it's going to be hard to manipulate without them. I mean, if you need the 9th term, could you just keep multiplying by 2? Yes. But y'all, if they start asking you for the 50th term, the 200th term, it's going to take up a lot of time on a standardized test to keep, doing something over and over and over again for 200 times. Okay. All right. Okay, hardest one. They actually have some exercises in Delta Math for this. We may do some tomorrow. Hardest one. Geometric sequence. First term, the value of the first term is 9. And y'all, they don't give you the common ratio. They skip and give you the value of another term. They skip and give you a value of another term. They do not give you the common ratio. Okay? So, first of all, let's write our formula. Okay? And in that last sentence, can somebody tell me what they're saying we're looking for? Like what we don't know, what they did not give us?
Common ratio?
Yeah, y'all, we got to find the common ratio this time. Y'all, that right there is what we don't know. And y'all, if this is what we don't know, we've got to have numbers for everything else. So y'all help me with some numbers. I bet y'all could tell me what goes in that spot.
9.
A sub 1 is 9. That's going right there. Now I need something to go in N and A sub N. Something's got to go in place of N and A sub N so that R is the only variable left. What is it? What's going to go for N and what's going to go for A sub N?
81.
Okay, where does it go though?
A sub N, or whatever it's called.
Yeah, and what goes in place of N? What goes in place of the N? It's there, you just gotta look. Y'all look right there. What are they saying? they're saying the third term, y'all, that's an N. The third term is 81. So y'all, the N is 3. The value is 81 for the third term. Okay, so 81 goes on this side, equals, the first term is 9, parentheses R, we do not know it, raised to the 3 minus 1. Good there? Okay, y'all, couple different ways to do this. This is geometric. Okay, we can't solve for R, not Math 1. So a couple of ways to do this. Put the left side under y equals in Desmos. Put the right side under y equals in Desmos. We can find the intersection. Okay? We can also use our table and our calculator. So let's see how that's going to work. So if y'all want to do this with me, let's go to y equals. Let's see if we can get this to work. 9 parentheses, I'm just going to use an X. I need a caret key. Open a parenthesis and put in 3 minus 1. If you're like, what if I just put caret key 2? It's the same thing. Y'all see that? Okay, go to the table. Tell me what we're looking for. And are we looking for 81 under the X, or are we looking for 81 under the Y? Y'all, we're looking for 81 under the Y. Remember, if it's on the other side of the equal sign, that's a Y. And we let R be X. Do you remember? We let R be X in the equation. See, y'all? The R is 3. The R is 3. In other words, the pattern is multiplying by 3.
Ms. Ratchet,
Yeah?
what do you click to get to the number?
If you look up here at the top right, table is written in yellow. So if you press second and table, okay? All right, let me see if Desmos wants to work for me. Let's just see. Y equals 9 X caret key 2 Gotta fix my window. Okay, and let's go to y equals and put in 81. Okay, I can see 2 intersection points. The good news to this is it would be multiple choice. And multiple choice would tell you to pick the positive one, R equals 3. It'd be multiple choice. So they wouldn't have a 3 and a negative 3. Okay? So R would be equal to 3. So a couple different ways to do that. All right, and last one, let's flip over. Notice the one in the middle. We had to use some type of graphing technology. Okay, now we're going to flip over to this one in the middle. Y'all, if this is linear, what you're going to find out is you don't need a calculator. You don't need graphing technology. We know how to solve linear equations. So here we go. Arithmetic sequence. The first term is 8. The third term is 12. Do y'all see that? They're not giving us the common, they're not giving us the D. So first term is 8, and they're telling us the third term is 12. They're telling us it's arithmetic. They're leading us to what formula to use. So our formula is A sub n equals A sub 1 plus D parentheses n minus 1. Well, in the question, what do they want us to find? Do you see? We are actually looking for the common difference And if that's the case, y'all, I have got to have numbers for everything else. So y'all help me with what goes where here. I got to have a number for that, that, and that. Start with something easy. What goes right there?
8.
Okay, the first term is 8. 8 goes right there. Okay, now you got these two guys.
12 and 3.
And which goes where?
12 is the first one, and then 3 is the end.
N is the term number is the third term, and we know that value is 12. 12 goes right there. Okay? So we've got 12 equals the first term, which is 8, plus D that we do not know, parentheses, and then 3 minus 1. This is going to be a real easy problem to solve. What do y'all want to do first? Did I hear distribute? Guess what? You don't have to distribute. What's 3 minus 1?
2.
Look. I mean, 3 minus 1 is 2. Now, if you distribute, you could still get the same answer, but, I mean, it's just you take an extra step. So now it's two-stepper. Subtract 8 on both sides. We get 2D equals 4. Divide by 2 on both sides. We find out that our common difference is 2. All right, folks, there she is. Okay, so y'all, I actually had a worksheet. Let's go ahead and try to set our equations up for the worksheet because we've got about 20 minutes. Okay, so let's go ahead and give it a shot. Okay, I would leave your notebook open if you wanted to see which kind of problem it is. I would leave your notebook open. All right. All right. All right, so what I want you to do is, I know we rarely have worksheets. I know that. Math itself doesn't have word problems for this particular thing, so we got to have worksheet. Okay, so let's go ahead and try to work through these. And then tomorrow I'll ask you to pull it out and we'll do all the solutions. Okay, but let's try to work through these. Maybe something to do is to go down through it and put an A or a G next to the problem. Because A and G leads you to the right formula. So maybe read each problem, put an A or a G first.